stuff where I go into the grab bag of what specific things we have seen in the past years. So I'm from a company called GoSip. We're really, really small. We're like 12, 13 people right now. We were founded in October 2000. That's quite a while ago. And we were really young and really inexperienced. And the first internet bubble was just about to burst. And that was good for us because we didn't get any money. And so when we started, we did anything that people would ask from us. We would program in PHP. We would sell servers. We would configure your mom's computer, whatever. And over time, we didn't go bankrupt, which is a good thing in itself for us. And we went through computer science studies, and the projects grew, and we grew with them. Today, we are a service provider. We do projects, and we have ambitious projects from customers like Zeit Online, which is one of the largest weekly newspapers in Germany. The two big unions in Germany are running their websites with us. We do hosting for a European agency and another large customer with 500,000 users that I can't name, unfortunately. And so software and the methods that we used to build it was the focus of what we did for a long, long time. And that was quite successful. We're very happy with these customers. They're happy with us. And there was another small part of our business all the time that we always did on the side. And that was back then, 2000 and the ongoing years, what you would call hosting. And a few years ago, and I think that was around 2008, something in that, we realized that our hosting offers were not what we were expecting, what we would like to give to people, and our customers didn't get what they expected. It was pretty unattractive, I've got to say. It was always done on the side, and we asked customers to, I've got to buy this server, and we didn't do enough investment on our infrastructure. We didn't have routine support desks, etc. And we changed that. We changed that, and we decided to, okay, let's do it right. And we now have a separate business unit within our company that takes care of operations and deployment of an infrastructure that we target at project businesses. So if you do websites, web applications, as we do, then this is kind of what we expect to be a nice environment to put stuff to. And I would like to reflect on what we learned on the way building that. And according to the roughly 626 open tickets in our internal tracker for new features, the way that we went isn't complete yet. We've got lots of ideas to do in the future. And what I'm going to talk about is extracted from 3 specific projects. It's from the infrastructure project itself, which we handle just as a regular project, and the European agency called OSHA, which is for Operational Safety Health. Yeah, we host them and the other unnamed customer that has 500,000 users on their intranet. So the big question is, at the beginning, what is a big application? So this is the specific setup that this European agency runs with us. Let's go through that quickly. All the dashed boxes are virtual machines. The yellow ones are backing services or running processes. The green ones are the pathways of HTTP requests, and the black ones, the black arrows, are non-HTTP communication going on. And so this site has 27 cores running. This one is actually quite a few of them, and runs about 80 gigabytes of RAM and about a terabyte of disk, and has about 550, 600 gigabytes of traffic per month. This looks very, very unconspicuous, but this is almost 400 domain names going in there. It's a pretty crazy setup. They set up new domains and new subdomains for everything. And the components that are in there, just reading them, there are ZOAP servers. There are ZIO servers. That's the ZOAP network database thing. There's Solar in there. There's Varnish. There's Nginx. There's HA proxy. There's Memcache running there. Static files are being served. There's LDAP in there. There's Deliverance. There's a link monitoring service. There's a specific tool for user management in LDAP. There is a Smart Print NG, which does PDF generation. There's a Java tool called Bird for reporting. There's a PostgreSQL. There are cron jobs in there. So looking at that, for me, a big web application is basically a composite of many, many different moving parts. And in our experience, selecting these services is a kind of negotiation process between administrators and developers. The communication typically goes like this. The developers say, well, we've got a store, we've got a customer requirement, they want the data, the user data to be stored in LDAP, and the administrators are going to say, oh, well, you're going to use OpenLDAP 2.4, that's what I can give to you. Or something like the developers coming in and saying, I need this package on this machine, and as an administrator we say, well, that package isn't supported by us, you've got to compile that yourself. And so this communication goes on all the time, trying to figure out, okay, what's on the administrator level, what's the developer going to do. And our goal, personally, is to make this as smooth as possible, to get rid of all the arguments that keep going in cycles when selecting these things. Unfortunately, we don't believe in silver bullets. Anybody waiting for a silver bullet for me? Not going to get it. So if we don't have a silver bullet, I can give you at least a general direction. And what we think is that you've got to divide infrastructure from application. And I'm going to go through what parts this touches and what this means. The rest of the talk is going to be divided into what happens on the infrastructure level, what happens on the application level. So infrastructure, from my perspective, is what we build to be able to have software run in an environment that keeps accumulating entropy. As a developer, you've got the benefit that when you develop your application, you have test runners and all these things, and these are really nice for the development. And whenever you try, you get an empty environment, run all your tests, it comes out green, excellent. The problem with production and operations is that you get a clean environment exactly once. After that, never again. At least in the places where it matters, on the databases, any persistent layers, etc. So, from my perspective, most of the work we do on the infrastructure level is to make it bearable to have entropy in the system and not lose all the flexibility at the same time. I mean, we've got software, right? And software is extremely flexible. We can change it all the time, except we have to accommodate the gap between physical stuff sitting around, and which is very inflexible, and virtual stuff like software that is very flexible. And you've got to gap that, and that's what we think infrastructure is for. So let's start from the bottom. Our customers expect us, and we like to deliver that we can control a large part of the environment in the infrastructure ourselves. We still have to draw a line somewhere, and for us the line is that we don't do data center. We buy stuff from the data center like power and uplink, the building itself, hands-on support at the location if we need like a disk exchange or something like that, and the racks. That's what we say. We don't do that. We come into the game where we say we're going to buy the servers, and we're going to buy the network, and we're going to put that in the racks, and we're going to take care of the cables. And we're actually, you can see this is actual the front and back of one of the racks we have in the data center. You can see that these are just regular servers. These are Dell Power Edges. And we're actually moving away from them. We've had really bad experience with Dell because we're a very small company, and the amount of money we give them is just too little for them to make any accommodations for the issues we ask for. And they just screwed up so badly that we stopped talking to them. We're actually moving to a small manufacturer. That's this box down there, which is in Germany. So if you like made in Germany, then we've got a small vendor who actually talks to us and who actually puts on their store which building blocks they're going to put in the server and not some relabeled things. On the networking side, something I can recommend is HP ProCurve. It's a really nice thing. We looked out for networking for a long time, and I kept hearing bad things about network components a long time, and the worst I heard about ProCurve is that they are like lice. Yeah, you get them and you never get rid of them, but that's not a problem. They're very standard conformant and very easy to set up. We like these. So when we actually look for physical components, then we look for a few things. Standards conformance, We don't want to be vendor dependent. We want affordability. We want a good bang for the buck. We don't want enterprisey things. We don't want complicated things. It should be really, really simple, and it should be an architecture that I can just go to the next store and buy something similar if that vendor should die. So these are just very off-the-shelf products. Some others that we talk to, they go into directions of like Cisco Unified Computing, but that means that you basically have to start with a huge budget to get started, and whenever that vendor changes a small part of their strategy that doesn't fit your strategy, you basically just have a huge block of unusable stuff sitting there. Same for InfiniBand, would give me much higher throughput, much lower latency on the network, but there's only 2 vendors worldwide, or maybe 3 that sell those, and it's really expensive. And I just wait for the standard stuff to get cheaper for 10 gig Ethernet and 20 or 40 maybe sometimes. The next layer on the hardware that we tackle is automation, and unfortunately, this is only second class in here right now. We use Puppet a lot. That's written in Ruby, so I get to write Ruby code every now and then. I don't like it. The things we look for in automation are 4 properties. We look for convergence, which means that when I describe a target state, I want the system that applies the automation thing to check for the difference between the is and the intended state and make any changes necessary to get the system to the target state. The second one I look for is idempotency, which means even if I run it twice or 3 or 4 times, it shouldn't do anything bad. It should remain stable. Versioning, we want to be able to have, even on the infrastructure layer, the ability to move between different versions of the automation code. And well, I already said it, I want everything as code. I don't want, as an administrator, to go in and to have to change something manually. And nowadays, the tools are all there. Puppet is really good at that on the system level. There's one thing that doesn't work quite yet, and that might be a systematic problem, is unmanaged. I can always say, move the system into a certain target state, but when I stop saying move it there, should I reverse that, or should I just leave it as it is? And just getting rid of stuff that you've put somewhere automatically, that's an unsolved problem. I think it's going to be unsolved for quite a while. So what we do with Python is that we have smaller scripts that assemble all over the place, more lower latency config changes, etc. On top, as a separate part on top of the hardware, we always use a virtualized environment. There's no reason nowadays anymore to put any production service onto physical hardware. There just isn't. The benefits are pretty obvious. You get hardware independence, especially from the life cycle. So if you see, well, we need a more powerful machine, well, just put it there, move the virtual machine image over, fire it up, and you've got a more powerful machine. Simplification, the services running in the VMs, they don't have to know about the specific hardware drivers or anything else anymore. So that makes these machines a lot more simple. Management, so you can migrate running machines from one physical server to the other without any interruption. And this starts introducing the idea of an application platform which is decoupled from the underlying infrastructure and built on top of it. So when I say infrastructure, I'm thinking in cables and physical machines, and I'm somewhere near the speaker. And as soon as we start virtualizing and seeing that we see a disconnect there, we're still not in the area of actual application deployment. We're somewhere in between, and this somewhere in between is what we consider a platform. And so the platform with us is a managed operating system and co-managed components. The operating system belongs still to the infrastructure guys, but you have some components that are just relatively hard to get right by yourself. Stuff like Postgres and OpenLDAP, and well, Nginx is pretty easy to get right, but still you don't want to manage all the details. And so what we do is we put co-managed components in there. These modern components like Nginx, they are very, very easy to have to get partial configuration from administrators and still allow via sudo and file permissions configure more details and the actual virtual hosts. So on this platform is where we think people should meet. So the infrastructure admins, they can log into the machines, and the application developers or their ops team can log into that as well, and both can look at what the application is doing. And there's no component that is in the runtime chain of the application that is hidden from the application developer. The developer can see all the components that make it up. We also tend to run the virtual machines very small. We usually say one process, one core, one virtual machine. The smaller you make them, the more the infrastructure level can actually do for you regarding flexibility, moving stuff around, etc. The bigger you make a VM, the more immobile it becomes. And obviously, virtualization needs to go hand in hand with automation, because if you get hundreds of virtual machines, you don't want to do anything manual with those. Another part on the infrastructure is monitoring. It's an extremely critical aspect, and we continuously, like on a daily basis, keep tuning and carefully changing stuff there. For one, if something is broken and our customer notices it faster than our monitoring, then we didn't do our job. Unfortunately, Nagios is good enough to use and bad enough to throw it out quickly. It's a dead end. There is no replacement ready yet. Everybody who's interested in going further from Nagios, this hashtag on Google we're going to help you. We do gather performance data with Nagios though, but this is one of the dead end parts. You get an updated data point like every 5 minutes, and that's way too little. Especially as we push the Nagios server quite far, every virtual machine, we get, with the automation, a lot of data points, about 70 different checks for an empty virtual machine. Everything from disk to CPU, to versions of software, to logged in users, processes running, memory, etc., etc. So that means that our Nagios server currently runs about 11,000 checks, and that puts a huge stress on it, and it really stretches it. As soon as I find a solution to get rid of it, I will. There isn't yet. And it looks like the future is going to be very, very modular to split up these aspects that Nagios actually does, like checking, get data gathering, classifying it, alerting. All these things are probably going to move into smaller parts that are exchangeable. Nagios lives on the infrastructure level, but customers do get access to it. That's okay from what I said regarding the platform. Nagios isn't itself a part of the runtime of the application. It's something that sits on the side. So it doesn't run in the virtual machines. It runs in the infrastructure. Customers do get logins and can see things and see the alerts. And the nice thing is that doing that, our infrastructure admins can see all of the application issues, and the application developers can see the infrastructure aspects of the virtual machines as well. So this is, again, something that supports the platform argument of being a middle ground where infrastructure and application people can meet. Another thing on the infrastructure level is help desk and standby support. There's a tool called Request Tracker. I think regarding the open source options, this or OTRS, Request Tracker has been with GoSip since 2002 or something like that, and we know how to twist it to do what we want. If I would start today, I probably would not use it. We use a lot of custom glue code, where we have a REST API that goes through the ticket queues and puts on SLA deadlines on things and does escalations, and the RT is reintegrated into Nagios. Nagios can generate tickets, the RT can acknowledge them and things like that, and Nagios also monitors the RT to check that we don't have any tickets running out of the deadlines. There's two process things that I suggest to people for doing help desk. One is a daily support review. Every morning, this is kind of like a stand-up meeting that we do, but before the actual stand-up in operations, we do a support review. We go through all open tickets. We check that that things that got stalled and reopened have somebody who's going to tend to them. We shuffle them around between the team, and then we say, okay, you're going to do this today. This is critical today. We're going to move this over. Review your queue every day just to stay ahead of what's going on. The second thing that goes in there is so-called interrupt shield. The interrupt shield is a role that a person in your team can have, and you either put that to one person all the time, but he's going to be very pissed off after a while, so you've got to move that around. Maybe do that in the morning and the afternoon. The interrupt shield is the guy who looks at the queue, answers the phone, and does things like that, and everybody else gets to work silently on whatever they actually have to do. And only if that guy can't solve the actual problem, the problem is really, really urgent, then he escalates that to some other party. If you're in operations, you can spend your whole day just by answering support emails. And you do want to deliver good support, but you also do want to do some actual work where you have to spend like a good amount of time, like 2 or 3 hours, focused on something. And the interrupt shield is an approach to do that. Okay, that's from the infrastructure level. That's what we do from the infrastructure to build a platform that you can run stuff on. And we're going to move over to the application and deployment stuff. When I do deployments, I've got 4 requirements that I want it to be. I want it to be quick. When I press the button, let's start from the bottom. I want to have a single button to deploy. I want to have one button to say push the updates or whatever there is to production. I want that to be quick. I want that to be repeatable. So I want to be able to do it once and twice and always have the same result. And I want it to be platform independent because I want my developers to use the same mechanism for configuring their app as I use for putting it on the production machines. We have a tool that is open source. It's not polished yet. We use it in production for said customers, and it's available. We built something with our experience with Puppet in mind. It's called Bateau. Bateau is the guy with the big guns from a movie called Ghost in the Shell. We chose that because there's a role called the Puppet Master in that movie, and so he shoots the Puppet Master, and Puppet Master is the thing that the puppet guys have. So this thing comes from the top. It's a model-based approach where you can, I'm not going to show any code. If somebody wants to see code, I'm happy to do that outside the circle. And on the sprints or in open space, it's nothing secret. It just takes a lot of time to explain. It's a model-based approach where I can model the service out of which components they exist, how they relate to each other, and it can be used everywhere. We give it to the developers. We use it ourselves for putting it to staging and production. It does not have any effect on runtime. This is a requirement that I also have. Is I don't want the deployment mechanism itself to be active while the application runs. I don't want to put more complexity on things. I want to have something simple that prepares the environment almost as if an administrator does it. I want orchestration. I want this thing to be able to know, well, if I take down the database, then the application server is going to go down and things like that. And I wanted to know that I've got 5 application servers, and when I'm going to update them, well, the load balancer can take care of 3 of them being down. So, well, I'm going to update 2 of them first, and I'm going to let them come back, update the other ones, let them come back, and I'm going to proceed with other stuff. That's what we want from that tool. I want convergency, same as before. I want that whatever state there is, I want it to do the necessary stuff to move it there. Also, idempotency. If everything's okay, then it should still be okay, and actually don't do anything when I push the button again. And reusability. I want to be able to, if I find a way to configure HAProxy in a very nice way, I want to do that same thing in the next project, and I don't want to rewrite all of that. So if you're interested in something like that, then talk to me or follow us on the, I thought I gave a URL, I didn't. Come talk to me if you're interested in that. I'm going to give you a URL where you can follow it. Apart from the deployment procedure, there is a second thing you've got to do. I already talked about this. You've got to choose components. And I hate finger pointing, but these are the good guys, these are the bad guys. If you're working on these and you're pissed at me, I'm sorry, but it is. Nginx, excellent for HTTP termination, Varnish for reverse caching. HAProxy, excellent for load balancing. PostgreSQL, nothing to say there. Memcached, postfix, supervisor, excellent components. I'm going to go into more depth for these. Really bad Apache. Some may be implementation problems. The problem is that if you have so many implementation problems that they pile up, you just become a nuisance to use. One example, Apache Kernel config test may tell you that everything's okay. You do a graceful restart. The thing completely crashes because it forgot to check that it can't bind the IP address. Bang. MySQL and Berkeley DB are both owned by Oracle. So we've got a company there that has 3 databases that they make, and personally, none of them I want to use. OpenLDAP is also very, very hard to get rid of. There's no good alternative, unfortunately. It tends to be very, very quirky. It might go into weird states when it comes up and says it's okay, but it's not. And I wish there was a better replacement for that. So you've got components, you've got a process to put something out there. Here's a third thing that I recommend that you establish is a minimal production-ready checklist. Here's ours. We want a same front-end configuration. I'm going to go into more detail what that means in a second. You need integration to system startup and shutdown. You need log rotation. You need, similar to log rotation, you need database maintenance. Databases tend to grow over time, and all database, Postgres has vacuum, MySQL has something similar. ZDB needs packing. These kinds of things, you need to set them up before it's too late. One of the things, because we're dealing with entropy, is that you can navigate yourself into a corner that you don't get out without a service interruption, and you want to do as much as you can upfront to avoid that. Fifth on the list is monitoring. You should at least have monitoring for all the processes you expect running, and not too many. All the ports open and responsive, and do weird things in the logs show up. And the sixth thing we recommend is put all your stuff into service users. Don't put them in users that are bound to a specific person, and don't run them as root. Just put them away in the service user home. Everything will be fine. One topic that pops up a lot is secrets management. So you're able to deploy stuff now. You've got a config. You've got you know what to do. You know which components to choose, how to roll them out. Here's one aspect that's very hard. And we found that this works very well. You've got database passwords, and you've got certificates and things that you need to distribute. And maybe you only intend to distribute them once, but for example, if you do disaster recovery, you've got to do that again. So what we do is this. Within our deployment utility, we create a config file per environment, like staging, production, etc. And we AES encrypt each with a different key, pretty long key, 20 or more characters. And we build tooling around that so that the deployment mechanism can transparently, you enter it only once, the passphrase only once, it decrypts it on the fly, and there's a safety build that when you change those files, you don't accidentally check anything that is not encrypted in. This works very well for us. So we have one file for each environment where we put SSL certificates, private keys, passwords for databases, passwords for external servers, etc. in, and a little bit of tooling around it to manage that. And that's actually a feature that we built into Bateau, for example, for us to make it reusable. Already talked about that for a while, a few times. Environments, you should have your setup multiple times, at least production and staging. They should be structurally identical, but staging can be smaller. You don't need all of these machines. If you think of the 27 machines that we have for the OSHA, for example, it's only 5 of them in staging. They're compressed a little bit, and there's a little bit of over-the-thumb decisions which we actually need and which we don't need. But you want to be able to check load balancing, failover, all these things as if it were the production environment. You need almost as much disk so you can accommodate the actual production data. So you copy it back every now and then, you test migrations, these kinds of things. And you can also hand this over to the customer to, before you deploy it to production, check out whether the fixes you did are actually working or not. One thing that I think Benji York said that to me, I don't know where this actually comes from, something when you do tests and preparation and simulations and whatever, fly what you test what you fly. Make it as similar as possible all the time, and only make small accommodations for changes. So for example, we use Bateau for the development environment for developers and MacBooks as well, and we only make very, very small adjustment where we say, okay, you're going to use a system installed Postgres here, or a local compiled Nginx here, or this or that. But we keep the same mechanism, and that makes it explicit where the changes are, where the differences are. I can actually look into a project and see, well, this developer, in his environment, he uses this parameter. This environment uses that. He uses that parameter, and then you can see, oh, it doesn't work for you because you're doing something different there, and you don't have to guess. Specific to web applications, I come from a ZOAP background, but I extrapolated this a little bit. Shared nothing. You should not have any state in your process that processes web requests that goes beyond what is needed for processing a single request. This helps for load balancing, so you don't have sticky sessions, etc. It also helps for availability. It helps for scaling. You can just take nodes up and down and nothing bad happens. Run many small processes. We even force 32-bit in the virtual machines on the platform, and I rather have 20 instances of 2.5 gigabytes of RAM each than have one huge instance. Here's an interesting detail. A customer of ours runs 64-bit and runs, I find, extremely high memory usage in their ZOAP processes, which are Python. And so they have like 24, 28 gigabytes of RAM in single process. What happens is they also run a lot of threads in parallel. Now, we all know the drill, but with 24 to 28 gigabytes of RAM, something that's going to bite you is the garbage collection. When that thing hits and it goes through the whole object, like this third generation cleanup, it can freeze the process for multiple seconds, and you don't want that. So more small processes, same thing as the virtual machines. It becomes all much more flexible if you have many small things than a few large ones. Don't bind ports early. If you start a process, get your process and your application ready first, then open network ports. Because as soon as you open network ports, requests will start to go in. Even if it's just the health check from the load balancer, overall it makes the system sluggish in the sense it takes longer to actually determine whether your application is ready. When you open the port, you should be good to go. You shouldn't then say, well, I've got the port open, but I'm still firing up these and these and these and these things. Don't do that. It's good for development, so you can hit Control R in your browser and then wait for it, and there it is. But for production, you want to listen as late as possible. Never store runtime configs in the database, because if you copy databases around and you have certain backend passwords, especially for external services, still in the database, then you're going to connect in a mixed version between production data and staging software and external service, and it's all going to be a mess. Never store runtime config in the database. Log long-running requests. If a request takes a long time, it starts blocking threads, and you're never going to have infinite threads. There are a couple of tools. In ZOAP, we use something called the long request logger, and I think there's a Whiskey middleware that does that. The idea is this. If a request takes longer than X seconds, then dump the stack trace of that thread every 2-4 seconds or whatever. So you get something that you can look at when you see, oh, it's stuck while it's waiting for the database, etc. Okay, there's the talk on that on Thursday. Excellent. This is a really good thing. Also, avoid synchronous external requests. Same thing. You have a limited thread pool. Don't do external requests, basically. Put them in some message queuing system. Make them asynchronous as good as you can. Also, avoid accidental write requests. If you do sessions, put them in something like Memcache or some very, very fast in-memory database. If you have something like Postgres for sessions, then the write requests are usually a burden on the disk. You don't want that. And also, if you think of scaling, then you usually want read requests to be really, really fast. And as soon as you turn a read request into a write request accidentally, it's going to be slow and it's going to stop almost everything. And the last one of applications, use feature switches. Build something where you dynamically, while the application is running, without reconfiguring it, you can turn on new features or turn them off, or if you notice that the load goes really high, then you can turn stuff off. This sector, this specific topic, there's a lot of details in there that is really interesting. For example, splitting up template rendering into separate processes and giving each a deadline of maybe 100 milliseconds, and if it doesn't come back, then, well, just leave it out. Really good ideas in this, but that's too detailed for this talk. process control, I already said, this is one component that we really recommend. This supervisor is there to turn anything into a daemon. It's written by Chris McDonough originally, really good thing. It means that also for system startup and shutdown, you only have one component to integrate. There is an additional thing for it called Superlands, and it has two plugins that I really like. One is HTTP OK. It sends off HTTP requests, and if it doesn't come back successfully, you can tell it, well, if that doesn't come back successfully, restart this process. This is good for if you have runaway threads or things that block your application, so you can restart them automatically. And the same as the memmon thing. You can set thresholds and say, if this process uses more than that amount of memory, then please restart it. Especially if, for us, as we have a 32-bit platform, we can give a lot of memory into the machine for disk caching, etc. But processes only have 3 GB of addressable memory. So when you get close to hitting that, then your application might actually get into a state where it doesn't crash, but where Python starts spitting out memory errors. And when that happens, you actually want to have a threshold that's a little bit below that and restart it. But obviously, your applications don't leak, right? If you look at it, there is no stable version, no officially stable version for 3.0 out, but the current release candidate or beta or alpha, whatever it is, we've been using it since ages, and it's good. Use that. For the Python environment, we use Virtualenv and Buildout, both combined. We use Virtualenv to get a clean environment, and we use Buildout to configure the working sets. Buildout might be a hammer, and there's a talk on that as well. Thomas, when's your talk? Also on Thursday. So all the follow-up talks to this are on Thursday. Buildout might look like a hammer. It's a really good tool, but remember, not everything is a nail. Don't try to do everything with it. For what you use it, use extends. It has a mechanism to split up config. Use that. And move the configs from the main directory. Move it somewhere else so everything. The recommendation I give is have one profile for base config, one for development that extends on it, production extends on the base, version definitions to a separate. Always use allow pick versions false. Otherwise, even during development, everybody will gonna get different versions of dependencies, etc. There's a switch called -t. Which is for timeout. It sets Python's default socket timer to something very low. If you deploy, you don't want your deployment processes to hang around for a minute or 2 minutes to notice that something blocks. Set it to T3. If it can't do it with that, then you actually notice that you have this problem that you're pulling from an uncontrolled external site. You shouldn't do that. Also, use Buildout at least version 1.5. I think that's the current major version. It's a lot faster because they improved the graph algorithms. Mr. Developer is there to get development packages, development checkouts from egg dependencies that you declared, and you can manage these correctly instead of making manual checkouts and rewiring development eggs, etc. The allowed hosts feature allows you to limit the hosts by host name and globbing that you can go to. This is very helpful to ensure that the deployment does not depend on external factors. And something that's also important to the performance of Buildout run is the latency to the mirror. See PyPyMirrors.org, they have statistics. We actually run a mirror, an official mirror in our data center, and I have a long-standing idea that is all the tools that use this index, like distribute and setup tools and pip, they should have a standard way to automatically determine the fastest mirror. This was really benefit a lot of use cases. Databases. When you use databases, as much RAM as you can afford. Seriously. We try to get as much memory into these virtual machines that have a database to accommodate the whole working set in memory for file system caching. Why? Because if you eliminate read requests on the disk, even if you have fast disks, if you eliminate read requests, then the disk is there to actually quickly process any write requests that come in. If you get them mixed up, then you're going to have a much slower performance. There is, if you do graphing on the performance, you're going to see that there's a sweet spot somewhere where the graph goes exponentially higher when you have enough memory. That's when you hit that, you know now it's okay. Now you have sufficient memory. Low latency network, you should have 100 microseconds or less latency on the network, and you are all using gigabit network today, right? Is there anybody who still runs 100? It's really worth it. Invest in it. It gives you tenfold lower latency, and that's something that boosts your performance in the application as well. Multi-core, if necessary, for databases. Postgres, for example, is really good at scaling with more cores. That's about the only use case where we put multiple cores in a virtual machine. And the disk usage of a virtual machine that runs a database should always be less than 40%, so you can do maintenance tasks and you can do restore. If you want to do selective restore, you need a lot of space to restore it into the running machine to reduce downtime. Quick story time. How more hardware makes stuff slower. A customer moved to a bigger machine, lots more RAM, lots more CPU, faster disk, and everything got slower. And we debugged that for a while. What we found is that suddenly we noticed a parameter called process exits per second, and this was in a 2-digit range. What happened is he would open a new Postgres connection for every query, for every single query. That eliminates both transactions, and it makes Postgres fork a new process about 20 times a second. If you increase the amount of memory, because you use fork in Linux, it initializes a copy and write data structure, and due to the huge amount of memory it had, about 10 gigabytes or 12, this suddenly didn't take 5 or 10 milliseconds, but 300. Now, if you multiply that, if you make 10 queries, instead of spending 500 milliseconds for opening connections, you suddenly spend 3 or 5 seconds just for opening connections and not doing any work, just by increasing the memory. If it's slow, you've got to debug it. Throwing more memory to it might not solve the problem, might make it worse. HTTPS termination. I'm getting under time pressure. Back to the Unix rule. Small things that do one thing well. Nginx, perfect for that. These are the use cases that you use it for. Basically, terminate HTTP, redirect it, reroute it, but don't do any work in here. HA proxy, really good thing. What we use a lot is the live statistics UI, where you can see queue lengths, throughput, all these kinds of things, and the performance log. You can always check for each individual request how long did it take, at what point in the queue in the front, in the pool at the server, waiting for the answer or connecting, and how many other requests were there at that exact moment. This is really worthwhile. Monitoring on the application level, I already said that, processes, ports, and logs. Model dependencies. If you get lots of checks, you need to model the dependencies between these checks, so if something bad happens, you don't get overwhelmed with all the different information. Check web page, Ruby thing. Really good tool to check a full web page from a command line no browser thingy to get CSS and images downloaded, etc. Has performance data integrated, does redirects and cookies and all these kinds of things, just to get a smoke test of the site. And if you can, use business process modeling to make an overall assessment on, if you look at everything together, do you have to get acknowledged if one of 10 application services is down? No, you don't. But at what threshold should you? The keyword for that is business processes. I'm running out of time. Reporting, the big rule, if a customer asks me to do reporting, then I ask him to go through that report with me a week after a 15 minutes phone call. If he doesn't want to do that, then I don't want to do the report. Simple as that. We only found this out quite recently to do it that way, but it's worthwhile. SLAs, the bottom line, friends don't let friends think in nines. Don't. Because then everybody wants 99.9999 whatever. Talk about how many minutes or hours of downtime are acceptable on a day, in a month, over the year. You don't have to make the same assumption of nines. If you talk about months and years, you can say 99.5, which is about 3.5 hours per month, and still say, let's do 3 nines per year, which is like 5 hours or something like that. 99% is easy. That's about 87 hours per year. 99.9% is really hard, and you always have to, You always have to align the technical measures you have with the organizational. three things to recommend. The practice of system and network administration, it's the Bible. Write this down, order it from Amazon. It's available on Kindle. It's the thing if you do system administration or operations. Bible. Heroku has a really, really nice document called the 12-factor app. I don't agree with all of that, but it's a very methodical approach. I really like that. And our documentation is available as well. You can look in there. Maybe there's something that inspires you. And I'd like to come to a conclusion. Use infrastructure, hardware, physical stuff to build platforms. And platforms should be transparent. Platforms should be something that both the administrators and the application developers can look at and see what's going on. No hidden shit. Don't put the load balancer somewhere in the cloud. Don't put this somewhere in the cloud. The platform should be something that is approachable and makes up all of the runtime of the application. And when you deploy an application, you should put it on a platform. Don't cobble together random services from the internet. Don't just say, oh, I'm going to run the Postgres from over here, and I'm going to do authentication over there, and I'm going to do this over here. If you do that in projects that are as complex as I've shown, you are not going to be able to predict what's going to happen when. Careful work pays. It's careful, it's nitty-gritty, it's detailed, and it sucks sometimes, but it pays. Buzzwords don't, especially if it's enterprise. If it's got enterprise in it, run. I don't think that infrastructure as a service and platform as a service in the extremes, like infrastructure as a service, Amazon, App Engine on the other end, I don't think they're a good answer to many projects like these. Many people are currently experimenting, and I like that. Don't yell at each other because somebody has a different idea. Everything is becoming more flexible, so we can even run serious projects on new things. Let's play.
Thank you very much. Now we can do a quick round of Q&A. First speaker. Okay, wait. I saw you, but he's near.
So I shared your slide on the very good things and the very bad things. So we have a question from Facebook, which is, what would you propose in place of LDAP, like in an enterprise context with legacy applications?
In place of?
Oh, LDAP, Open LDAP.
I can't. As I said, I wish there would be.
So
I don't have.
Don't deal with legacy application in that case, or you just
No, we use it. We use it.
Sure.
We don't have an alternative, so we use it. As I said, sometimes it sucks.
Fine.
The thing is, this is one of the points where we say we turn OpenLDAP into a co-managed component where we say, okay, here's the set that we know works well and that we're gonna take care of in the long run for the whole infrastructure for all the applications that run there, and you only get fill in the blanks, and then over time we figure out, okay, don't do that. That's the nitty-gritty stuff.
You mentioned Nagios.
Yep. Hey.
Sucks for sort of metrics collection. Have you looked at anything like Graphite or any of those systems?
We looked at it. We didn't get it right, and we didn't have time to look at it any deeper. The thing is, as the monitoring sucks people were going to tell you, they're not like a group of people. They're more like somebody shouted shit on the internet. The answer is going to be that monitoring, metrics collection is going to be a smaller set of tools that do their things well. Graphite might be one answer to it. It's a very, very dynamic environment. We're looking at a couple of things in parallel, but I don't want to say anything specific. Sorry.
Hi.
Yeah.
I have two questions. One is actually regarding Puppet. Did you also try Fabric?
Yeah, we did. Actually, Fabric is what I used to run deployment first, but Fabric is a purely command-driven thing. And then I went a step further and built Bateau in version 0.1 on it, using Fabric for the SSH remoting. And Fabric actually now is also using an external library for the SSH control, and Fabric moved out, and I'm just using the SSH control itself. The point is, building a tool in Fabric that has idempotency and convergence is relatively hard because you don't have a model. So you need something on top of it. And when I started doing that, I noticed that I don't need the things that Fabric gives me.
I have another question regarding databases. We are also using virtual environment to run MySQL. I mean, all kinds of reasons. How do you store the database files? Do you store them on the virtual machine itself, or do you prefer them storing on the volumes? Because
when I say virtual machine, I mean really a virtual machine as you would expect it if you were really naive. So the root file system is persistent and everything just works like a computer. So yeah, we just store them on the root file system. The root file system is backed currently via iSCSI over a gigabit network. We are going to introduce Ceph later this year to make the storage layer suck less. But this is something where my understanding is virtualization is there to make stuff simpler. And the whole idea of non-persistent images and then using an additional thing it doesn't make it easier. It makes it more complex. And I hate that. Sorry?
Wait.
you have to take regular snapshots to recover from a failure, and on databases it's much more difficult as compared to a web server. So either you would want to set up replication or store database file on persistent storage.
We don't do. Are you talking about snapshots of the virtual machines, or what kind of snapshots are you talking about? Okay, we only use snapshots for the virtual machines to run actual file system backups. So we run Bacula with the virtual tape library, and last question or? Okay, we run Bacula on a virtual tape library, and that connects to the storage servers. The storage server has an LVM volume that is the root disk of the virtual machine, takes a snapshot on that server, mounts it again, makes a file system-based backup, throws away the snapshot, and off it goes. That works very well. We also have coordination within the virtual machines to tell them the databases, we're going to go into backup mode, do something, then we're going to take a snapshot, we're going to let it run.
Hi.
Hey.
I saw block diagrams for Solar and LDAP in your second slide, I think.
I didn't get the beginning.
Solar and LDAP, which you're talking to, how much are you testing the code that interacts with those before it's deployed?
You mean how much we test the code that automates the LDAP config?
I think I need to. I'll catch you afterwards if I know.
Sure, yeah, I'm happy to, yeah.
Okay, thank you very, very much.
Thank you.
Been really great. I just remind you one last thing, that tonight there is the coding competition. Please come. Thank you very much.